Okay then guys, let's have a little look at the paper then. This is the C1 paper for EdExcel AS level Mathematics, January 2011. It's a 90-minute examination paper. So let's flick down the instructions, have a quick look at them, and have an overview look at the questions, just to simulate what we might sort of think about for this examination. We need to fill the boxes at the top, of course, prior to the examination. We can't take a calculator in to this particular examination. Here's the instructions. The candidates answer all questions. There's plenty of room to answer the question in the space provided. We've got a booklet and tables. Full marks to answer all questions, of course. We've got the marks on the right hand side to give us a rough guide. 11 questions in this paper, 75 marks in total, 24 pages. Answer to parts of questions are clearly labelled, so we need to put part A, part B, part 1, part 2. Sufficient working to make it clear to the examiner the methods you've used, and answers without working may not gain full credit. Okay, so there's the instructions then. Question 1, let's have a look at this. Simple powers, rules of indices here, simplify these expressions. Very easy question to do, and some easy marks obtained there, so it's a good question to start with, and it is question 1. So that's an ideal starter question. Simple little bit of integration for the second one. Integrate term by term, run along the row, and it's simple powers. So again, that's a very easy elementary question to do. Number 3, surds. Rationalize the denominator here, write it in the form of p plus q, find p and q. Very nice question. So 1, 2 and 3, no surprises there, which is good news indeed. Question 4, sequences. We got this relationship here describing the first point and then the subsequent points generated for this particular sequence. Find A2, which is easy enough. The first 3 add up to 0, and then find the value of C. So again, that's a nice easy question to follow through on. So question 4 is good, and ample room to put our answers. Question 5 is this sketch with some asymptotes at 2 and y equals 1, and you've got this curve here given in the sketch. So you've got this sketch of that function, and then we have to draw some other functions, 3 functions here, fx minus 1, and where it crosses the axes. And the asymptotes, yeah, nice question there, that's good. So that doesn't look too bad as well. Simple little curve sketching. 6 APs, arithmetic sequences. For some of the first 10 terms is 162. That would be easy to obtain then, wouldn't it? 6th term is 17. Write down another equation in A and D, and then solve for A and D. No more than simultaneous equations basically there. So very easy, straightforward question for number 6. 7. So it's dy dx, separating the variables and integrating. We can just put in this initial condition here to get the arbitrary constant that's generated. So again, nice question to do, and can be done in double quick time. So that's good. Number 8. Quadratic. 2 distinct rules will impose the discriminant. B squared minus 4ac will be greater than 0, won't it, for 2 roots. So this quadratic, presumably in k, will come out when we do that. And then we just have to look at the set of possible values of k when this quadratic itself is greater than 0. So that's a nice question. So it's looking like a very nice paper to do, isn't it? With all these questions relatively user-friendly. Number 9. Straight line. K is a constant. A is on the line. Find the value of k if that point lies on that line. The gradient of L1. That would be easy then, wouldn't it? And then we need to find out properties of another line perpendicular to L1. So that's just properties of straight lines there, isn't it? So let's go to the next one now, which is question 10, which will be the penultimate question. So sketch this cubic, sketch this function here, showing the points where the curve crosses the coordinate axes. That's good. And then we need to follow through on the previous work to work out when this equals 0 and the number of real solutions. that problem there. So again, that doesn't look too bad. Might take some time, a little bit of time, but not too bad. Here's the last question then. Question 11. The curve C has this equation, it's a cubic. Differentiate to get dy dx. Input these values into here to show that P lies on C. Then the normal to C at the point P. So we can work out the tangent from dy dx. The normal will be, when you times it by the tangent gradient, you get a product of -1. So we can get the normal gradient, and then we rearrange it in this form here. So again, that's fairly good. Nice question to do. So the paper looks fairly user-friendly, doesn't it? With no major problems, no really nasty looking questions. And so there's no reason why we shouldn't just go through that sequentially, especially since the first few questions are very user-friendly anyway. So it's worth just following the paper through. And then the good idea with this is 90 minutes is when you go through all the paper, and you've done all the questions, tick them off, and then double check. If you finish early, don't go out. Double check your paper, and then if you manage to double check everything, then focus on triple checking the questions as well. Use every possible second you can when you're in an examination. After all, it's only 90 minutes, and you've done an awful lot of preparatory work in order to do as well as you can for just these 90 minutes. So it's well worth using the whole of this time up every last minute when you're doing these problems. So all the best if you're taking a C1 paper then, guys, and look forward to catching you again in another revision session. Cheers!